Okay, so we're looking at a sequence, and it is a function whose domain is the set of positive integers. Each corresponding value is called a term of the sequence. Okay, this here at the first, this is function notation. We said we would do something f to the number 1 and we would get a result. Okay, so that's function notation, and this is going to be our sequence notation. Okay, when we're talking in sequences, we'll refer to them as A1, A2, A sub 1, A sub 2, A sub 3, and so on. Okay, so up here it said a function whose domain is the set of positive integers. So if I've got my n and my f of n, right, n is 1, 2, 3, 4, and so on. F of n is going to be whatever, depending on what we did to the number. Okay. All right, so we're going to find the first 5 terms of a sequence with the given formula. So here's our formula. A sub n equals 2 times n minus 7. Okay, so if I replace n with 1, that's going to be my first term. So 2 times 1 minus 7, or negative 12. Okay. A sub 2, replacing n with 2, so 2 times 2 minus 7, which would give me negative 10. A sub 3, 2 times 3 minus 7, which gives me negative 8. A sub 4 would be 2 times 4 minus 7, which gives me negative 6. And A sub 5 is 2 times 5 minus 7, which gives me negative 4. Okay. All right, so then I write that out in sequence format: negative 12, negative 10, negative 8, negative 6, negative 4, and then that sequence would continue on. Okay, so that's my answer. Okay. B, same thing. We're finding the first 5 terms, so we replace n with 1 in all the places that we have an n. Okay. We do that arithmetic and we get negative 1. And we would do A sub 2, replacing n each time with the number 2. And on that one we get positive 1/3. Then we do A sub 3, replacing n with 3 this time. We get negative 1/5. Continuing on, A sub 4. Gives us positive 1/7. Just realized the negative kind of blended there, so I'm going to make it a little clearer that that was negative 1/5. Okay, and then A sub 5, replacing n with 5. And we get negative 1/9. Okay, so our sequence is negative 1, positive 1/3, negative 1/5, positive 1/7, negative 1/9, and so on. Okay, so I just want to point out that the way we alternate signs from negative to positive, it came about because of our, just realized I haven't been writing on the screen at all. Okay, so you might want to pause and take a moment to catch up with the writing, or rewind and listen again. Okay, so the negative, positive is happening because of this negative 1 to the power. Negative 1 to an odd power will give us a negative value. Negative 1 to an even power gives us a positive value. Okay. Okay, so question number 2. Write the next 3 terms of the sequence. Let's find a formula for the nth term of the sequence, then find A sub 12. Okay, so you're looking, what's the pattern going on here? Well, it looks like 1 over 1, 1 over 2, 1 over 3, and so on. So I would expect the next to be 1 over 6, 1 over 7, and 1 over 8. So So that would be the next three terms of the sequence. Find a formula. Okay, so now we got to figure out, well, what are we doing to n to create these fractions? Well, here n is 1, here 2, 3, 4, 5. So it appears that a sub n, the term in the sequence, is found by putting 1 over n. Okay. All right, so if we did a sub 12, we would replace n with 12, and 1/12 would be the expected 12th term of the sequence. Okay. All right, starting over, 3, 5, 7, 9. Well, appears to be the odd number, so the pattern seems to continue on 11, 13, and 15. And here n is 1, 2, 3, 4, 5, 6, and 7. So what are we doing to 1, 2, 3, 4, 5, 6, and 7 to get those numbers? Okay. Well, we're adding 2 to get to the next number. Okay. So there's a difference. There's somehow 2's factoring in there. But that's not what we're doing to n, because 1 plus 2 is 3, but 2 plus 2 is not 5. So that's not working. So what I looked at was kind of like a table format, so I just wrote them out. I said, well, what's happening here? We're increasing by 2. Here we're increasing by 1, and that continues. So this means this is a linear function, and 2 is the slope of that function, so that would mean that a sub n equals 2n, right? But 2 times 1 does not give me 2. 2 times 1 gives me 2. Does not give me 3. 2 times 1 equals 2, so I need to add 1 more to get 3. Okay, so there's my formula. So I answer the first two, and then a sub 12 would be 2 times 12 plus 1, which is 25. All right, let's look at the next bit. We have negative 1, 1, negative 1, 1, negative 1, so I'm assuming 1, negative 1, 1 would be the continued pattern. But what does that have to do with my n value being 1, 2, 3, 4, 5, 6, 7, and 8? What am I doing each time? Okay. I'm not adding a number. I'm not subtracting, multiplying. Okay. So it's just 1. So this one took a little more thought, and I finally figured it out that this means that a sub n would have to be negative 1 to the nth power, because that's how we get that alternating negative positive, is we change the power. Odd powers give me negatives. Right? Even powers give me positives. Okay. So when I come down to the next one, I've got 1, negative 1, 1, negative 1, 1. It seems to be starting with negative 1 starting with positive 1 instead of negative 1, but it's the same sequence. Okay? But that means when n is 1 now, it's positive. Okay? When n is 2, so the same formula is not going to work, is what I'm saying. So what did we do? Well, we're still going to have that negative 1 power, right? But instead of n, right, we need this to be n to be even, so we're going to add 1 to it, and that'll make it even. Okay. All right, so those are my two formulas, and then I have my rest of my sequence. So now I need to know what is a sub 12. So here it would be negative 1 to the 12th power, which is 1, and here a sub 12 would be negative 1 to the 12 plus 1 power, which is negative 1. All right. So a sequence in which the difference between any two successive terms is constant is called an arithmetic sequence. Okay. The difference means we subtract. Okay. common difference means it's going to be the same difference for the whole thing. So if we come down here, if I subtract 7 take away 4, I get 3. 10 take away 7, I still get 3. 13 take away 10, still get 3. 16 take away 13, I still get 3. So D is 3. Okay? So if I'm going this way now, right, I'm going to add the 3. So similarly here, I'm going subtracting back this way, I get negative 5. Subtracting back this way, I get negative 5. Continuing, I get negative 5. So D equals negative 5. When I go this direction, I'm going to add negative 5. So that'll be 25. I add negative 5, I'll get 20. Okay. A sequence in which the ratio of every pair of successive terms is constant is called geometric. So here we have ratio, common ratio. This is found by dividing. So we would have 6 over 2 equals 3. 18 over 6 equals 3. 54 divided by 18 equals 3. So we're dividing back. Okay. So R is 3. So as we go this way, we'll multiply by 3. So we get 162. Multiply that by 3, and we get 486. Similarly, on B here, negative 40 divided by 80 equals negative 1/2. 20 divided by negative 40 equals negative 1/2. Negative 10 divided by 20 equals negative 1/2. So R equals negative 1/2. So if we multiply by negative 1/2, we'll get 5. And we multiply by negative 1/2, and we get negative 2.5.